In Python, Lambda functions stand as a compact way to represent small, anonymous functions. In other programming languages, they're also expressed as Lambda expressions or function literals, and are a key concept in functional programming. Their basic syntax is as follows: Lambda, arguments, followed by a colon and an expression. This structure highlights a few essential characteristics of Lambda functions, such as simplicity. They're defined using a single expression. This contrasts with regular functions defined using the def keyword in Python, which can consist of multiple lines of code, as you're already familiar. Then we have anonymity, where Lambda functions do not necessarily have a name. However, if needed, they can be referred to by a variable. Then we have single-use nature, where they're especially useful for one-off simple tasks that don't require the reuse of the function elsewhere. Lambda functions shine when used with built-in Python functions like sorted, filter, map, and reduce. And these functions accept another function as an argument, which makes Lambda functions a convenient choice for these style of chained operations, as we'll go on to see in the hands-ons as well as future lectures. For example, in the case of sorting with the sorted function, for sorting a list of objects based on a particular attribute, Lambda functions can serve as a quick key generator. Here you have a piece of code, for instance, where people is a list composed of JSON-looking dictionary objects with a key name and age, name Alice, age 30, name Bob, age 25, and you have another variable defined by a sorted function taking in the people list with the key set by a Lambda function, Lambda person, person age. In the case of filtering with the filter function, to filter elements of a list based on a condition, Lambda functions can act as the condition checker. For example, here we have a list called numbers from 1 to 6, and the even numbers variable is defined by a list that is composed of a filter function where the function itself is a Lambda function, here Lambda x mod 2 equals 0, applied on the numbers list. In the case of mapping with the map function, Lambda functions can be used to apply a transformation to each element in a list. And when reducing with the reduce function for performing a cumulative operation over a list of items, Lambda functions can be used with reduce from the functools module, as expressed in this example over here, where we're importing the reduce method from the functools module. We're defining a list called numbers, with numbers ranging from 1 to 4, and we're calculating the sum by conducting a reduce operation where the function is defined by a lambda with 2 inputs. In the hands-on lecture to follow, we'll use these concepts in real-world examples like log processing and stock price monitoring. See you there.